Hey everyone, continue the next question type. We have finding complex roots to a quadratic. So you are now able to actually find quadratic roots where we have b squared minus 4ac less than 0, or we have complex coefficients or imaginary coefficients. So let's start with the first one, x squared minus 4x plus 5. So clearly we can't factorize to give us real solutions, so we're just going to use the quadratic formula and well, b squared minus 4ac, 16 minus 20 over 2a. 2 plus minus 16 minus 20 is minus 4, so we have root minus 4 over 2, which you can also change to 2 plus minus root 4 times I over 2. Now why we can do that is because we have a cert that is actually a real number, right? Root AB equals root A root B if and only if one of them is a real solution or a real number, where we have root 4 as the real cert. So you know that root 4 is 2, so we have 2 plus minus I, and these are our roots. 2 plus I, 2 minus I. Now, you can check your answer with your GC. Just don't forget to set it to the A plus BI mode, and you can just key in, right? So let's say I'm going to pick 2 plus I square minus 4 bracket 2 plus I, and then you should get minus 5. All right, you can add the plus 5 if you want, but you know that if you don't get minus 5, then that's the correct answer. So, and you also notice that the roots are the conjugates of one another, and that is because it falls under the conjugate rate theorem, where we will explain in the next video. Now moving on to the other quadratic equation, z squared plus 4z plus 4 plus 2i equals to 0. Now you notice that we now have a mix of real and imaginary coefficients. Of course, I didn't give the example where all are imaginary coefficients, but the method is still the same, where we will now involve the quadratic formula again, because we're not going to try to factorize 4 plus 2i. There is many ways to do that. All right. So following the quadratic formula, minus 4 plus minus b squared minus 4ac. b squared is 16. 4ac 16 plus 8i, so minus 4ac minus 16 minus 8i. Then lastly over 2. Minus 2 plus minus. Now, we will get minus 8i on top. And the problem is, some of you might try to do this, root minus 8, root I. This, you can't do that because you know that this is a imaginary number. This is also an imaginary number. We can't use that if neither of the numbers are real. However, you can do root minus I and root 8. That works as well. All right, this works, the other doesn't. But whatever it is, when we have square root of minus 8i, we need to solve it, right? Just like the previous video where we know how to solve the square root of complex numbers. In quadratic equations, the first way that you should try to use is using your GC, where you simply type in root minus 8i and you get a very nice number, so which means that you can actually use your GC and no need to solve it by hand. However, if you were to use your GC and you get like a lot of decimals, then it's probably, you know, solving by hand, basically doing whatever we did in the previous video. Nonetheless, we will have root minus 8i as 2 minus 2i, right? Lucky for us, it is a nice integer number for both the real and the imaginary. Now, some of you might ask, why not consider minus 2 plus 2i as well? Why not write plus minus 2 minus 2i? Well, we already have a plus minus here, so we're going to already consider both of the roots, so it doesn't matter which one we use. We just need to use one, and we need not consider both. So we have plus minus 1 minus I. Please add the brackets, otherwise it will be very confusing and you might get it wrong. So the first root would be minus 2 plus 1 minus I, minus 1 minus I. The other root, minus 2 minus 1 is minus 3, minus minus I is simply plus I. And you notice that now the roots are not the conjugates because we have an imaginary coefficient of 4 plus 2i. But whatever it is, you still can check your answer with the GC by, let's say if I take minus 1 minus I and put it to order z, plus, or rather minus 4 minus 4i, this should give me back minus 4 minus 2i, and yep, I do get minus 4 minus 2i. Alright, so there we have it, how to solve complex roots, and kind of importantly, how to check your answers.